Okay, as we start the last topic of Chapter 5, this is Section 8, and it's applications. And if you recall, applications are word problems. A couple of the key words that they'll have matching for is the Pythagorean Theorem, the hypotenuse, the leg, and a right triangle. Well, let me give you a little background on that. There was this Greek fella that developed this idea about triangles, and this is a right triangle in which there is a right angle of 90 degrees, and then the side opposite that 90-degree angle, the right angle, is called the hypotenuse. And the sides adjacent to this right angle are called the legs. And he developed, and you wonder how they do this sometime, that if you designated this leg as, let's say, B, and this leg as the letter A, and the hypotenuse as the letter C, that if you take the square of this leg plus the square of this leg, it would equal the square of the hypotenuse. And the formula would be A squared plus B squared equals C squared. And that is the Pythagorean Theorem. So if this side were 3, and this side were 4, this side would be 5. This happens to be that special 3, 4, 5 right triangle. So if you squared 3 and squared 4, that would equal 5 squared, or 9 plus 16 equals 25. Okay? So this is something we'll use a little later in some of the problems, but I thought I'd introduce it at this stage. And again, here we're working on word problems. We've done a few before. We want to, again, develop a strategy. You have to read it a couple of times. The square of a number. Well, we don't know what that number is, but that's the square of a number. Plus the number is, we said, was equal to 240. So this is a quadratic equation, and the only way we know so far to solve quadratic equations is to put them in standard form. So that will be n squared plus n minus 240 equals 0. And the only way we know to solve it is to factor it. And now we're looking for two numbers whose product is 240, but have a difference of 1. So how in the world would you possibly figure that out? Because who knows all the factors of this? Well, the strategy for it would be to take this 240 and get the prime factorizations over here. So we know 2 will go into there, 2 will go into that, 2 will go into that, 2 will go into that, Now we have a 3 and a 5. So these are my prime factorizations. Now, looking at these numbers, can you see here a 15? And can you see here a 16? And 15 times 16 have a difference of 1. And our sign will be, this will be a plus, this will be a minus. And we could go through the steps of equaling each of these, but our numbers are going to be n equals negative 16 or n equals 15. So for this example, your answers are a negative 16 and a negative 15. That's going to be one set of answers. And then it could also be 15 and 16. So these are the answers to number 5. And you might say, oh, I did that pretty quickly. But, as I mentioned before, I have sat down and worked these out. And as I sat down to do them, it was quiet. I had to read the question over and over again, try to figure out what my unknown was, what equation am I going to use, and then I would see if, in fact, once I solved it, it made sense. So these are all skills that they want you to work on for topic 5.8. For number 6, it says a scrapbook is 3 inches longer than the width. Find the length and width if the area is 108 inches square. Well, let's make a scrapbook here. So this is a rectangle, and we don't know the width, but we do know the length is 3 more than the width. So we have made a little diagram and put this information into the diagram. And we know the area is 108. So what formula are we going to use? Well, area equals length times width. So we have 108 equals the width times width plus 3, which is our length. So this is going to become 108 w squared plus 3w. And I'm going to take the 108 over to this side to put it in standard form. And there's my equation. Now again, if I were doing this for the first time, I'd have to spend, a little more time thinking about it, but I've done the thinking already. As I showed you earlier, I've done these. So now we have to factor. And now we're looking for factors of 108 that have a difference of 3. So let's use that same technique that we used. 108, 2, so that's going to be 5, 4, 2, this is going to be 27, This is going to be 3 and 9, 3 and 3. So, as we look at this, it happens to work out the same. This is 9. This is going to be 12. 9 times 12 is 108. And I need the 12 to be a positive and this to be a negative. So I'm going to have my width be 9 and my length then, 9 plus 3 is 12, and it checks. So my width over here is 9 and my length is 12. 9 times 12 is 108. And how did we find it? Well, we made a diagram. We put our information into the diagram. We got our formula. We put our formula into standard form. We factored it, equated each of these. And by the way, there's no such thing as a negative 12 width, so we sort of reject that answer. And there we get a 12 and a 9 and a 12. And we use this technique to help us factor it. As we get into example 7, there's a lot of words, so I'm not going to write it all down, but I'll show you the strategy of what I did. They said there was a picture frame. So I made a picture frame. It said this picture frame has a dimensions of 16 centimeters by 20 centimeters. So I put that there. It said now within that picture frame was a picture that had the area of 192 square centimeters. But there was like a little margin around the outside. That is like a little mat that they had. And they wanted to know what was the dimensions of that little mat that they put on top of that picture. So the overall was 16 by 20, and then they had a sort of a frame that went inside it, a little mat that let the picture show through. They're wondering what's the measure of that. I'm using the letter W to indicate that because there was a W there, a W there, a W there, a W there. I could have used any other letter, but I chose the W. Now, what kind of formula can you make out of it? Well, remember, it's area equals length times width. So that's what went on in here. So I want to find out what that W is. Well, if we have for the length, can you see this length to give you this area inside? I have to take away this W and this W. So that's 2 W's there. And for this width, I had to take away some W's. So this is going to be 16 minus 2 W's. So there's my new width, and there's my new length that will give me this area. So my original formula was length times width equals my area. And you might say, wow, this is getting challenging. Well, we're going to FOIL, That gave me this. I did my outers and my inners, and that gave me this. And then I did my last, and that gave me that. And there's my area. Now, I have a quadratic equation that I have to put into standard form. So I put my 4w squared over here, my minus 72w there. I subtracted 192 from both sides, and I got 128 equals 0. So there's my standard form of the quadratic expression or equation. Then I said, well, let's try to make it smaller numbers. So I saw that I could divide everything by 4, which is what I did. And then I got this equation, which is not the same, but it's equivalent. And then I had factors of 32 that add up to a negative 18. Put in my correct signs, and I have w equals 2 or w equals 16. Now, whenever you do a word problem, and this is to the second degree, we're going to get two answers. But we have to then look at the answers and say, does it make sense? Could this width of that little frame that we've put on top be 16 inches? Think about it, and the answer is no. So we reject this answer, and our answer is actually the width is 2 of that little edge frame that we're putting over the mat to cover our center picture. And again, all they gave me was the original problem. I had to develop the technique of making a picture, figuring out I could have used an X instead of a W, or any letter, get my initial equation, foiled it, put it in standard form, simplified it, factored it, got the answers, and then did one answer make sense and the other not, and that's what we found. And then if we were to check it, if we had here 16 times 12, that would be 192. Okay. Number 8 was very similar to the one we just did, so I'm not going to do that one. But I did work it out in my little booklet, as I said before. There's number 8. Very similar. Again, we want to show you strategy for doing these, not necessarily to do them all. Now, for number 9, again, you may not remember this, but here's how it's done. They're talking about 3 odd integers. Now, what are these odd integers? Well, we don't know. Well, 5, 7, and 9. And by the way, 3 consecutive odd integers. 3 consecutive odd integers. 5, 7, and 9. Now we want to translate that to algebra. Well, if the first integer is 5, we'll call that x. Well then, if x is 5, how do we show 7? Well, x plus 2. How do we show 9? x plus 4. Now, by the way, this algebraic representation, this is like universal for any three odd consecutive integers. So this is what you would need to know to be able to do number 9. Now, as you read on, it says the square of the first, which is right there, plus the square of the third, which is this one, which is right there, equals 170. So there's your equation. But you see, you need to know odd integers, sort of what they're talking about. So then, what do? Well, you have to put it in standard form. So this will be x squared. Now we're going to use that special technique to square a binomial. And now remember, this is a perfect square trinomial. We're going to combine like terms. And I'm going to transpose this to the other side. And since I already have it worked out, I left out one step there, so I'm going to have to, this is going to be a negative. I'm going to subtract 16 from that, so that'll be 4. How about 154? Let's go with that. We had a little change of rooms, so we'll pick up a little bit where we left off, that we ended up with this equation as we worked on example 9. And when we factored it, we ended up with x is 7 or x is a negative 11. Now here they want to know the 3 consecutive integers. Well, if 7 is the first one, 7, 9, and 11. That would be a set of 3 consecutive integers. That is, if we squared the first one and we squared the last one, that would add up to the sum they gave us before. But keep in mind now that we have another possible number, a negative 11, a negative 9, and a negative 7. That if we squared this number and squared this number, that would be an acceptable answer as well. So this is number 9. As I mentioned, as we do these, the strategy of reading the word problem carefully, figuring out what basic equation you're going to use, setting up your variable, gets to be quite challenging. So let's take a look at this one where we have a pole. This is our basic pole, and we have a wire attached to that pole. And that wire is 34 feet long. And again, the use of a diagram is very helpful. Now, what they're telling us, the distance from where that wire is pegged to the pole, we don't know that. but the height of the pole is this distance plus 14 feet. So I have some other numbers in here that'll come up later. In fact, let's take that out here for now. Okay, so again, this is a right angle, and this is a Pythagorean problem. So our first side that we don't know is x, which we're going to square. We're going to square this other leg, which is there, and it's going to be equal to the square of our hypotenuse. So x squared is x squared. We squared this using our special formulation. Square that, multiply these two, double it, square the last term, and then we squared 34, and we got this. All right, we're going to group like terms. And we're going to transpose this over, and it becomes a negative 960 equals 0. So now we have a quadratic equation in standard form. Now we could try to factor that, but again, the smaller the numbers, the better off we are. So we're going to divide everything by 2, and we get then x squared, and I have that incorrect here. This is going to be 14. That's better. And then I subtracted this, and we have that. Now again, we're looking for factors that have a difference of 14. And we could use that same technique we used before. And that's actually what I did, because there's no magic button here to figure these out. And I worked it out, and that's what we got. So then when we had x minus 16 equals 0, this is going to be our value of x. Here, x would equal a negative 30, and you can't have anything that has a negative 30 value, so we reject that one. And x is 16, so x is 16. 16 plus 14 is 30, and our hypotenuse is 34. So those are our answers, and again, it took me quite a while to do this, and we wanted to show you, again, illustrate a strategy for doing this. There's lots of work. I'm not sure how many of these difficult ones you're going to have in your particular course, but that's an example of this one. We'll do some more too.